This naturalrefrigerants.com article is being read by an automated voice. Interview: HYTING's founder discusses catalytic hydrogen. Air Heating, Peak Shaving, and Global Growth by J. O. Haraldson. Published March 16, 2026. Tim Hanig, founder and managing director of HYTING, spoke with naturalrefrigerants.com about the company's hydrogen catalytic air heating system. He also discussed its potential for peak demand shaving in industrial facilities and plans for scaling and global expansion. The technology's potential applications include process heating, auxiliary automotive heating and absorption cooling, producing air streams up to 300 degrees Celsius, 572 degrees Fahrenheit. Hanig told naturalrefrigerants.com. However, due to limited hydrogen availability, HYTING is focusing on the most practical and economically viable market, the growing industrial space heating sector. With the peak shaving, we can provide a positive business case to customers today, despite high hydrogen cost, Hanig said. The unit operates at 98% efficiency, with 1 to 2% of the heat energy used for a valve, a fan, and the electronics. In February, HYTING commissioned its first catalytic hydrogen air heating system in a new industrial facility in Offenbach, Germany. Flusys, a producer of pumps and fluid systems for industrial applications, installed a hybrid heat pump/catalytic hydrogen system to heat its 1,000 cubic meters, 35,300 cubic feet, production space with the 10 kilowatt, 2.8 tons of refrigeration, HYTING unit supporting peak heating demand. The interview has been edited for length and clarity. How does the technology work? What about flammability? Tim Hanig. It's a simple process, with catalyzer technology developed since the 1970s. We mix hydrogen and air in a non-flammable concentration well below 4%, lower flammability limit. We push the mixture through a catalytically coated core where the hydrogen reacts with the oxygen in an exothermic process to generate low humidity air at 300 degrees Celsius. At that temperature, it oxidizes everything, even carbon monoxide. It's a super clean hot air stream that we mix in an air handler to produce the desired temperature. For safety, we deliberately keep the hydrogen feed and the HYTING unit outside the building. That avoids flammable level accumulations, even in microleaks. What benefits does the technology offer? What market conditions factor into it? Our technology is not a heat pump competitor, but a synergistic hybrid solution. Heat pumps operate efficiently at 40 degrees Fahrenheit, 4 degrees Celsius, but as it gets colder, COPs go down. Meeting the coldest ambient temperature heat loads requires exponentially bigger heat pumps, with only a third of the unit's capacity used in 90% of its operation. In Europe, the electrical connection price is based on the heat pump's capacity. We cut that peak off. By sizing the heat pump for the capacity used 90% of the time, we lower capex per kilowatt, while our hydrogen technology handles the coldest days. With the ability to modulate the unit's output from 1 to 10 kilowatts, 0.3 to 2.8 tons of refrigeration, we control the inlet air temperature. Without a heat exchanger, nearly 100% of the generated heat goes directly into the building's airflow. What does production and deployment look like for HYTING? Any plans for marketing outside of Europe? Besides the unit already installed, we have 3 more in various stages of deployment, with 2 going into operation in March. Right now, we offer 10 and 50 kilowatt, 2.8 and 14.2 tons of refrigeration. Heating capacity units with plans to scale to 300 kilowatts, 85.3 tons of refrigeration, especially as we see a significant opportunity for dehumidification in processing heat applications. Using decarbonized electrical sources to achieve the required process temperatures can be difficult. Some innovative companies command a price premium for the sustainable production of their products. If end users are willing to pay a higher price, we can produce ultra-clean green heat. We plan to build 30 hydrogen catalytic units this year, 50 to 100 next year, and expect production to grow into the thousands within 3 to 4 years. With the units being manufactured by our industrialization partner, EBM Pabst, a German manufacturer of fans and heating technology, we can scale production as needed. We are focused on the European market, but with maturity, we expect to expand into new regions in 2027. Beyond Europe, we see potential markets for the systems in Canada and areas in the US where energy rates are high, particularly California, New Jersey, and Texas. We are also exploring opportunities in Brazil, which has significant hydrogen activity, and in China, where hydrogen has been designated a key technology under the country's 5-year plan.